Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into Chapter 6 of our journey through CPU scheduling. Specifically, we'll be exploring the basic concepts that form the foundation of this crucial aspect of operating systems.
That's right, Victor. CPU scheduling is a fundamental part of how operating systems manage resources efficiently. It's all about deciding which process gets to use the CPU at any given time. This might sound simple, but it's actually a complex and critical function that directly impacts system performance.
Absolutely, Sheila. To kick things off, let's start with the basics. Can you give our listeners a clear definition of what CPU scheduling is?
Certainly. CPU scheduling is the method by which the operating system decides which process or thread gets to use the CPU at any given moment. It's like a traffic controller for computer processes, ensuring that the CPU is always busy and that all processes get their fair share of CPU time.
That's a great analogy, Sheila. Now, to understand CPU scheduling better, we need to talk about something called the CPU I/O burst cycle. Can you explain what that is?
Of course, Victor. The CPU I/O burst cycle is a pattern that processes typically follow. A process alternates between two states: CPU burst, where it's executing instructions, and I/O burst, where it's waiting for I/O operations to complete. Understanding this cycle is crucial for effective CPU scheduling.
Excellent explanation. Now let's introduce a key player in CPU scheduling, the CPU scheduler. Think of the CPU scheduler as a restaurant host. Just as a host decides which party gets seated at a table next, the CPU scheduler decides which process gets to use the CPU next. Sheila, can you elaborate on the role of the CPU scheduler?
Absolutely, Victor. The CPU scheduler is a part of the operating system that handles the removal of the running process from the CPU and the selection of another process based on a particular strategy. It comes into play when a process switches from the running state to the waiting state, terminates, or in some systems, when a process switches from running to ready state.
That's spot on, Sheila. Now let's dive a bit deeper and talk about two fundamental approaches to CPU scheduling: preemptive and non-preemptive scheduling. These are crucial concepts that often come up in operating system interviews.
You're right, Victor. These are indeed important concepts. In preemptive scheduling, the operating system can forcibly remove a process from the CPU to give its time to another process. It's like an emergency room triage system where a critical patient can interrupt the treatment of a less urgent case.
That's a vivid analogy, Sheila. And non-preemptive scheduling?
In non-preemptive scheduling, once a process starts using the CPU, it continues until it either finishes or voluntarily releases the CPU, typically when it needs to perform an I/O operation. It's like finishing your meal at a restaurant before leaving the table. You can't be asked to move mid-meal.
Excellent comparisons, Sheila. These concepts are crucial for understanding how different operating systems manage their resources. Now, there's one more key component we should discuss: the dispatcher. Can you explain what the dispatcher does?
Certainly, Victor. The dispatcher is the module that gives control of the CPU to the process selected by the CPU scheduler. It's responsible for context switching, switching to user mode, and jumping to the proper location in the user program to restart that program. The time it takes to stop one process and start another running is known as the dispatch latency.
That's a great explanation, Sheila. The dispatcher plays a crucial role in the actual implementation of the scheduling decisions made by the CPU scheduler. It's like the stage manager in a theatre, ensuring that each act transitions smoothly to the next.
Exactly, Victor. And it's worth noting that while we often talk about these concepts in terms of processes, modern operating systems apply many of these same principles to thread scheduling as well.
Absolutely right, Sheila. As we wrap up, let's quickly recap the key points we've covered today. We've discussed the definition of CPU scheduling, the CPU I/O burst cycle, the role of the CPU scheduler, the difference between preemptive and non-preemptive scheduling, and the function of the dispatcher.
That's right, Victor. These concepts form the foundation of CPU scheduling, a critical function in operating systems that directly impacts system performance and user experience. Understanding these basics is crucial for anyone looking to delve deeper into operating system design or preparing for technical interviews in this field.
Thank you, Sheila, for this insightful discussion, and thank you, listeners, for tuning in to another episode of Operating Systems Crashcast. Join us next time as we continue our exploration of CPU scheduling strategies.